Your physics class. So student, in our last lecture we have discussed correction of myopia and hypermetropia. So by using concave lens and convex lens we correct the vision or we correct the defect myopia and hypermetropia. So student, today we have to discuss refractive defect of vision, means another defects after myopia and hypermetropia. I'm going to share a video. First of all, you see this video and get conclusion and learn about defect of vision.
An eye is referred to as a refractive defect of vision. In myopia and hypermetropia, the images are not focused on the retina by the eyelids, and hence the images are blurred. Myopia and hypermetropia are refractive defects of vision. Another refractive defect of vision is presbyopia. It is caused by a decrease in the power of accommodation of the eye with age. We know that the power of accommodation of the human eye enables us to see both far away and nearby objects clearly. What will happen if the power of accommodation of the eye decreases? The eyelids will not be able to adjust its focal length efficiently to focus the image of both nearby and far away objects on the retina. The power of accommodation of the eye usually decreases with age. Generally, the near point of the eye recedes. People with presbyopia generally find it difficult to see nearby objects clearly. So why does the power of accommodation decrease? We know that the power of accommodation of the human eye is a result of the action of the ciliary muscles and the flexibility of the eyelids. There may be two causes of a decrease in the power of accommodation. One, gradual weakening of the ciliary muscles with age, and two, diminishing flexibility of the eyelids with age. Let us understand how the weakening of ciliary muscles causes a decrease in the power of accommodation. We know that the ciliary muscles are responsible for changing the curvature of the eyelids. When the ciliary muscles contract, the curvature of the eyelids increases and the eye focuses the image of a nearby object on the retina. Thus, one can clearly see the nearby object. When the ciliary muscles are weakened, they will not be able to contract enough to increase the curvature of the eyelids while focusing on a nearby object. The nearby object will not be clearly visible. Thus, the eyelids will not be able to focus the image of the nearby object on the retina. In such a case, the near point of the eye will recede. Similarly, when the flexibility of the eyelids diminishes with age, its curvature cannot be changed efficiently while viewing nearby or far away objects, and the power of accommodation decreases. Let us discuss how presbyopia can be corrected. Just like hypermetropia and myopia, presbyopia can be corrected using corrective lenses. Rekha's aunt has presbyopia. She is finding it difficult to see nearby objects comfortably. Which corrective lens shall we recommend her to use? We recommend her to use a convex lens. A convex lens will provide the necessary convergence to the light rays coming from a nearby object and focus them on the retina. The nearby objects will then be clearly visible. Notice that in both presbyopia and hypermetropia, the near point of the eye recedes. Both these defects can be corrected using a convex lens. So how is presbyopia summarize what we have learned. Myopia, hypermetropia, and presbyopia are three refractive defects of vision. In presbyopia, the power of accommodation of the human eye decreases with age. Generally, the near point of the eye recedes. There is gradual weakening of the ciliary muscles or diminished flexibility of the eyelids with age. A convex lens is used for the correction of presbyopia. When a person suffers from both myopia and hypermetropia, they require bifocal glasses for correction. A type of bifocal glasses consists of both concave and convex lenses for facilitating far and near vision, respectively.
So student, in this video we have learned about how a presbyopia defect occur. So presbyopia defect due to a age or weakness in ciliary muscles. So there are adjusting or focusing power is decreased, so that's why object not see it clearly and image not form on a retina. So in this case we using convex as well as concave lens, bifocal lens to help to correct the presbyopia. So next one is correction of vision. So correction of vision using the corrective lens. A concave lens is used to correct near eyesight of a myopia, and convex lens using in farsightedness is a hypermetropia and presbyopia. So power of corrective lens. How many power of a lens? So power of a lens decided according to the focal length. So power is defined as 1 upon f, means 1 upon focal length, and focal length in meter. So if power of a concave lens is negative and then convex lens is positive. So concave lens power is negative and focal length is also negative, and in case of convex lens focal length is positive and power is also positive. So now we going to practice a question 2.9 on your SB8. So she can need a power plus 2.5 diopter. So first of all students, the SI unit of power of lens is diopter, which is noted by capital D. So for correcting her vision, identify the defect she is suffering, state the nature of corrective lens to calculate the focal length of a corrective lens. So students, first of all calculate the focal length of a corrective lens. So power is equal to 1 upon f. After putting the value, power is 2.5. The focal length is 40 centimeter. So Shikha, nature of a corrective lens. So nature is according to Shikha suffering hypermetropia. Unless Shikha suffering hypermetropia and corrective lens is convex lens and focal length is 40 centimeter. So focal length of by using lens formula is 1 upon f, 1 upon v minus 1 upon u. V is the distance of image and u is the distance of object. So student, next one is NCERT exercise page number 198. The far point of a myopia of a person is 80 centimeter in front of eye. What is the nature and power of a lens required to correct the problem? So student, far point of myopic eye is 80 centimeter. That means can clearly see object placed 80 centimeter from the eye or a close. So we know that far point of a normal vision is infinity. So according to numerical, the image is formed b is equal to minus 80 centimeter and object is minus infinity. So after the putting in a formula, the nature of the correct length and power of correct length, first of all we calculate the focal length 1 upon f 1 upon v minus 1 upon u. After the calculating, the power is 1 upon f. After the calculating the value, focal length is the minus 80 centimeter, and after that we calculate the power of a lens. So power of a lens is minus 1.258 diopter. So that means is used by concave lens to require correct their problem if power is minus 1.25 diopter. So student, this type of question is your must and very important for your final board exam. So you have to practice and take your queries related to these numericals. If you have any problem, text to me anytime. Thank you.